As we enter the year of 1933 with Packard, we finally realize existing conditions as they are today. The keen competition in the motor car industry and the exacting demands made by the buying public. To fulfill these demands, we wish to introduce to you the best performing, most beautiful and most comprehensive line of Packard cars ever presented. They will be known as the Packard 8, Packard Super 8 and Packard 12. This is the Packard 8 1001 with 127-inch wheelbase. This series will carry 4 body types: 5-passenger sedan, 5-passenger coupe sedan, coupe roadster, and the permanent top coupe. The top used on this coupe is covered with imitation Leitner, instead of khaki material, which adds greatly to the appearance. This is the 1002, with 136-inch wheelbase, the chassis carrying 12 body styles. Notice that the belt molding has been widened and raised 1 inch and now blends into the one-piece corner post without a joint or break. This type molding is used throughout the rest of the line. We have increased the angle of the windshield to 19 degrees, which adds to appearance, and the body sill line has been altered to conform with the change of the frames. The Packard Super 8, or 1003, is 150-inch wheelbase and is the first of the series using the large 8-cylinder motor. This chassis carries only 1 body type. The body shell of this model is the same as the 5-passenger sedan body used on the 1002. All closed bodies will be equipped with serials for radio and safety glass. The Super 8, or 1004, chassis will carry 12 body styles. Packard bodies are made up of carefully selected hardwood lumber properly kiln-dried and amply reinforced by metal braces. Their wooden framework before the metal panels are applied is painted to protect it against moisture. The metal before applying is rust-proofed, and where the metal is joined to the framework, it is insulated with a rubber compound to prevent possibility of squeaks. The Packard 12 or 1005 has a 142-inch wheelbase and carries 10 different body types. All Packard bodies are thoroughly insulated against noise, heat, and cold. Insulation has been provided in every part of the body where annoying squeaks or rattles might occur. All sedan limousine bodies will have a dome light in the front compartment. The Packard 12 or 1006 has 147-inch wheelbase and will carry but 2 body styles: 7-passenger sedan and 7-passenger sedan limousine. This model is built to the greatest degree of luxury and without a doubt represents the finest in motor car transportation. The height of the radiator has been increased to improve appearance. The temperature of the cooling system is controlled by thermostatically operated shutters. The radiator core area and thickness have been increased to provide more efficient cooling. The appearance of the front end has been improved by the removal of the battery and toolboxes. Improved fender brackets have been developed to ensure minimum fender movement when traveling over rough roads and giving greater rigidity to the entire front end. Solar ray headlights are used on the complete line. The design of this light is that it provides improved road lighting when meeting approaching cars and without glare to the driver. The single bar bumper is used on all Packard 8 models, and the stabilizer type bumper is used on the Packard 12. Wire wheels with drop center rims are standard. Tire size on the 1001, 1002, 1003 and 1004 is 17 by 7 and, on 105 and 106, 17 by 750. Full-type bumpers are used in the rear instead of bumperettes. The rear of the car is more clearly finished in detail. 2 taillights are standard equipment on all cars. The wheelhouse and rear fenders have been altered for improved appearance. Packard body ventilation is provided through a new type front door and rear quarter glass mounting. It permits the proper ventilation of the car's interior at the will of its occupants absolutely without draft. The outside air can be directed into the car, or the glasses can be adjusted at such angles as to circulate the air into or out of the body by the use of cowl ventilators and adjustable windshield. Adequate control ventilation is provided under all conditions to meet the most exacting requirements. The cushions and seat backs have been improved to provide the greatest comfort and freedom from fatigue. A center armrest has been added to the rear seat as standard equipment on all models. Front seat armrests may be had at an extra charge on all models except the Packard 12, on which they are supplied as standard equipment. The driver's seat has an adjustment range of 4 inches on all type bodies. The front seat on all bodies is built into the body pillar posts as a one-piece construction, providing additional strength. The front compartment is roomy and accessible. Under the driver's seat is an opening for access to the battery. The openings in the floorboard for the pedals are fitted with molded rubber seals which exclude draft and dirt. The accelerator pedal improved tight footrest will be appreciated by those who drive long distances. The instrument board has been improved in appearance. The instruments are conveniently located and easily read. The 2 familiar glove compartments are used at each end of the panel. The gasoline gauge is also a crankcase oil level indicator operated by pressing the button under the instrument board after turning on the ignition switch. We have located the brake selector valve at the left of the instruments. The Packard 8 power plant is of strictly Packard design and manufacture. The 5 outstanding features of the new 8 power plant are more power, faster acceleration, smoother and more quiet operation. More economy on fuel by approximately 10%, and more horsepower at less RPM. The left side view of the motor shows several mechanical features to be explained later. The 1001 and 1002 develop 120 HP at 3200 RPM. The 1003 and 1004 develop 145 HP at 3200 RPM. The new front motor mounting uses a single block of rubber. This results in an exceptionally smooth operating motor. The fan has 4 blades staggered to eliminate noise. The rear of the motor is on rubber fastened to the transmission housing. The frame brackets are on an extra crossmember extending across the frame under the transmission. This tight mounting in the rear plus the single-point suspension in front permits a free movement of the motor in rubber. This eliminates torque reaction periods or rough spots from the entire driving range. We have retained our rigid crankshaft construction using 9 main bearings which provide the desired rigidity for eliminating vibration. On the front we use the vibration damper which functions to dampen out the disturbance set up by power impulses. Complete force feed lubrication is maintained through the motor. There has been a slight change in camshaft design which affects valve timing. We now open the intake valve 30 degrees before upper dead center instead of 20. The valves are operated from the camshaft through drop forged rocker arms with rollers lubricated by force feed. Front-end drive is accomplished through a flexible 1.5-inch chain. This operates off the crankshaft, driving the camshaft and generator. The timing chain is adjustable through the generator mounting. Another improvement in our 8 motor is the new connecting rod. Notice the heavy construction at the bearing end of the rod. The cooling fins on the connecting rod bearing cap add greatly to the bearing strength and promote rapid radiation of heat from the bearing. The connecting rod bolts have been increased in strength approximately 30%. These improvements will greatly prolong the life of rod bearings. Manifold, dual carburetor, air cleaner and silencer used on the 8 motor differ from the conventional type downdraft design in that we use downdraft carburation and updraft manifolding. This construction prevents raw fuel from being carried directly into the combustion chamber and, combined with balanced fuel passages, provides exceptionally good gas distribution to all cylinders. One section of the carburetor supplies gas to each 2 end cylinders and the other to the 4 center cylinders. The automatic choke eliminates hand choking when starting and automatically adjusts the choke for proper motor operation until the correct temperature has been reached. Instant warm-up is assured by the direct heat attained from all 8 cylinders on a hotspot in the manifold. This heat is automatically controlled by a thermostat which holds the valve closed when the motor is warm, thereby providing an ideal manifold temperature at all times and ensuring proper breaking up of the gas mixtures. A carburetor air cleaner and silencer ensures the utmost in quiet motor operation. Attached inside the right glove compartment door are complete motor starting instructions for the convenience of the owner. We are using 2 coils whose location combined with short spark plug wiring contributes considerably to ignition efficiency. The ignition system is an improved design of high capacity and is built to ensure long life under high motor speeds now developed without frequent adjustments. Full automatic control of the spark advance is one of the features of the Packard ignition system. Ignition timing marks stamped on the vibration damper. The mechanical fuel pump combined with a vacuum pump for windshield wiper operation is on the motor left side and driven by a push rod through the crankcase from a specially provided cam on the camshaft. The fuel line under the bonnet has been insulated and every precaution taken to prevent vapor lock. A 20-gallon fuel supply tank is used on the 1001, 25-gallon on the 1002, 1003 and 1004, and a 32-gallon tank on the Packard 12. Notice the oil gauge connections on the crankcase. By electric connection to the gasoline gauge on the dash, this operates as an oil supply indicator when the small button at the edge of the instrument panel is pressed with the ignition switch on. The Packard 12 power plant develops 160 horsepower at 3200 HP. It now has double fan belts, a 5-inch generator and combination fuel and vacuum pump. The rigid crankcase and shaft construction is retained and full force feed lubrication is used. The upper half crankcase and block are cast together. Large water capacity passages have been provided. A new connecting rod provides more metal around the bearing which eliminates possible bearing flexing. A change has been made in the automatic valve adjusting mechanism, principally in the valve take-up piston and valve arrangement. Observe the difference between these 2 valves. The new type fits in the assembly in a reversed position from that of the old type. The new valve is more positive in its action and is less subject to sticking in that the valve operates inside a piston sleeve. The rocker lever is mounted on roller bearings and the rocker lever is mounted on anti-friction bearings. Adjustment of rocker lever take-up is accomplished through an eccentric cam in the center of rocker levers operated by a piston feed by oil which forces the cam to rotate, closing the gap between the rocker lever and valve stem. The maximum amount that can be taken up through this adjustment is approximately 40 thousandths of an inch. On the Packard 12, we have what is known as cool downdraft carburation. To prevent raw gas from entering the combustion chamber, there is a chamber just below the throat of the dual carburetor which is primarily a hot spot. When heavy ends fall into that position, they are immediately vaporized and passed on into the motor. For servicing purposes, these manifolds are easily removed as an assembly. The Packard clutch is used on the 1001 and 1002 is of the improved single-driven member type. The clutch-driven disc is of a special design and provides a spring action under the lining which is responsible for an extremely smooth clutch action. The lining is of a special treated material selected for great resistance to wear, heat and hard usage. The clutch assembly is mounted on the flywheel and is protected from grit and dirt. The clutch used on the Super 8 and Packard 12 is of a heavier single-plate type. The driven plate is 1 inch larger in diameter, 12 inches overall. The spring pressure has been increased, and to compensate for this additional pressure, the throwout fingers are longer and mounted on anti-friction bearings which with the aid of anti-friction bearings on the clutch pedal have reduced the required pedal pressure for release from 45 pounds to 25 pounds. With these design improvements and through smooth application with rapid radiation of heat, our clutch service should be increased approximately 3 times. Note, automatic clutch control with a selector button located on the dash will be supplied when desired at an extra charge. The Packard transmission is of the selective 3-speed synchromesh type. Quiet in all forward speeds. Angle set rear axle is used through the entire line. The hypoid style gearing pioneered by Packard is used. This type gear materially increases the length and strength of the spiral gear teeth. The bearings in the axle construction have been greatly increased in strength. A feature connected with our pinion shaft mounting is the addition of the bearing filter washers. When assembled, these bearings are filled with oil and sealed with these felt washers through which the oil is filtered before it reaches the bearings, ensuring them of a much longer life. An angle-set rear axle permits the use of an extremely low pinion drive and allows the pinion to run in oil at all times, resulting in better lubrication and quieter operation. Oil capacity has been increased to 6 pints. The standard gear ratios are 10:01 and 10:02, 4.38 to 1. 10:03, 10:04 and 10:05, 4.41 to 1. 10:06, 4.69 to 1. Special ratio of 4.06 to 1 furnished as special equipment. The Packard steering gear is of the worm and sector type. Just the right amount of reversibility is provided in the steering gear to give it a self-restoring tendency after making turns. The steering gear ratio is 17 to 1 and the steering geometry is greatly improved. The steering wheel is 18½ inches in diameter and made of hard rubber over a steel spider. The Packard 12 steering gear is of a different design from that of the Packard 8. It is a worm and double roller type. The ratio is 18.6 to 1. On the Packard 8 and Super 8, the mechanical duo servo type brake is used. The drum diameter is 14 inches and width of lining 2¼ inches by 1/4 inch thick. To develop a better balanced brake and to eliminate troublesome equalization, we have used on the left front brake shoes a lining which is less in width than that used on the other 3 wheels. The brakes on the 10th series have 3 times the reserve capacity of those used last year. The increased lining thickness provides approximately 65% increased service. The brakes in reverse have the same power as when going forward, and the hand brake operates on all 4 wheels. The effort that is usually required in making a brake application has been decreased by the use of a vacuum-operated power cylinder. To control the operation of the vacuum cylinder, a valve is operated through a reactory type of linkage designed by Packard, attached to the brake pedal. Through this type control, it is impossible to lose braking through loss of vacuum, thereby giving us a safety feature that is not found in all vacuum brakes. Another important and desirable feature of the power brake is the provision that has been made for adjustment of the brake action to suit the individual preference of the driver. This adjustment is made through a selector valve operated from the instrument board and provides the driver with 4 different degrees of brake pedal pressure. The brake drums are a composite of steel and iron construction. A liner of cast iron is centrifugally cast into a steel drum. These drums resist the scoring effects of abrasive matter exceptionally well and have the ability to absorb heat very rapidly. They are sealed against water or dirt, which gives a longer life to lining. The Packard 12 brake is the same design except that the drums are 15-inch diameter and use a 2½ inch lining. Front axle and steering knuckle construction on Packard cars is of the most rigid type. Safety and strength are requirements of front axle construction and have been obtained by properly designed parts. The steering knuckles are on ball bearings of large capacity, spring-loaded and requiring no adjustment. The steering connections are of the self-adjusting ball socket type. Springs used on Packard are fitted with metal covers which retain the spring leaf lubrication and protect them from water and dirt. Springs of different carrying capacity and rates of action are designed to suit the particular chassis and body type. The Packard frame is of pressed steel heavy channel construction, adequately braced by heavy crossmembers, ensuring road stability. The 10th series frame is approximately twice as rigid as last year's frame. The frame X-member has been changed by the application of a reinforcing plate extending from the center of the X-members to the side frame member. This eliminates lateral twist of the frame, providing a perfect foundation for the body. Spicer joints are used through the entire line. The former intermediate bearing on the drive shaft is eliminated by using a heavier balanced shaft. Packard automatic chassis lubrication is provided on all cars. An oil supply tank with a built-in pump actuated by motor vacuum forces oil through small copper tubes to points requiring lubrication. Connections at these points are metered so that each moving part is lubricated in accordance with its needs. The shock absorbers are two-way hydraulic, equipped with ride control, providing adjustment to meet the requirements of the passengers. This is a feature that was introduced by Packard and provides ride control over any type road at any speed. Also built into the shock absorber is a static valve which acts as a stabilizer on the compression stroke of the shock. It is located on the lower side of the shock, has a permanent adjustment when assembled and does not require any service. The shock absorber connecting links are of the oilless type. We have shown you many features of the new Packards, the finest ever built. Let us not overlook the fact that our job is not only to sell and service these new cars, but also, and almost more important, to service the ones already sold. For the year 1933, let us devote ourselves with all our ability to the further development of our service departments. We must do everything possible to keep our customers coming to our service stations for their needs. Now is the time to do some self-judging and adjusting for the battle ahead. Are we doing an efficient service selling job? Have we got a good reputation for fine service? Remember always, better service means more new car sales and every owner a salesman.